Now we discuss fundamental theorem of arithmetic. Okay, statement is like this: every composite number, you know what is composite number, other than prime number. Prime number means it containing the factors only 2. Suppose 5, it can be expressed 1 into 5, only like that. 7, 1 into 7, only 2 factors, 1 and 7. Suppose when we consider the number 6, 6 can be expressed 1 into 6. One more is there, 2 into 3, like that 2 can be used for expressing that 6, 1 into 6, 2 into 3, but 2 is, that is 6 is not a prime number, that is considered as composite number. Other than, more than 2 factors, that is considered as composite number. And here also like that, every composite number can be expressed as the product of primes. Any composite number can be expressed as the product of prime numbers. And this factorization is unique. If you know, everyone got the same factors always, apart from the order of in which the prime factors, okay, order is not problem. Suppose someone writes 6 as 2 into 3, other one write 3 into 2, both are same. Like that the content is considered as the order of. Okay, let's say I can give one example. Suppose 140. The prime factorization already you know, that is like this: 140 can be written 2, that is dividing by 2 it becomes 70, again dividing by 2 it is 35, and 2 is not possible, therefore 5, it becomes 7. Then 140 can be written 2 into 5 into 7, that means 2 here 2 times, therefore 2 square into 5 into 7. This is the prime factor. Suppose the composite number can be expressed as the product of primes like this. Here 2 times, therefore we can use the power 2 raised to 2. Then another example, 156. Same way we can dividing 156 as again 2, that is 78, then 2, 39, then 3, 13. Okay, then 2 square into 3 into 13, like this we got. Therefore, 156 is equal to 2 square into 3 into 13. Like any other number, suppose 72, that can be find out like this: 72 dividing by 2 first, that is 36, again dividing by 2 it is 18, then again dividing by 2, 9, then 3, only dividing by the prime numbers 3. Therefore, 72 can be written 2, 1, 2, 3 times into 3 square. Okay, like this. Therefore, every composite number can be expressed like this. It's known as the fundamental theorem of arithmetic. The fundamental theorem of arithmetic is used for finding HCF and LCM of 2 numbers or more than 2 numbers. That's no problem. Okay, we can find out by using fundamental theorem of arithmetic. Okay, then let's I can give an example, that is 72 and 120. We need to find out HCF of 72 and 120. We can find out the prime factorization of these 2 numbers first. Suppose 120, 2, that is 60, again 2, that is 30, again 2, that is 15, 3 and 5. Now this 120 can be expressed 120 equal to 2, 1, 2, 3 times, that is 2 cube into 3 into 5. 120 can be expressed like this. The same way the next number 72 also like that. 72 2 times, that is 36, again 2, that is 18, 2, 9, 3, 3. Now it can be expressed 72 as 2 cube into 3 square, because 2 3 times and 3 2 times. Therefore 2 cube into 3 square. Now we can find out HCF. First we can find out HCF. HCF is given like this: the product of the smallest power of each common factor. First you find out which factor is common in these 2. When we consider these 2, here 2 and here is also 2, and here 3, here is also 3, here 5, here not 5. The common 2 and 3 is there. HCF told like this, the product of the smallest power of each common smallest power. Here 2 is common. When we comparing these two, here 3 times and here also 3 times. Therefore, 2 cube. Same we need to write. The smallest, both are same there. When we consider the common factor 3, here 3 2 times, here only 1 time. Therefore, the least power we need to write 3 only. The least power is like that. Therefore, answer HCF is like this, 2 cube into 3. Already know the 2 cube means 2 into 2 into 2, that is 8. 8 into 3, that is 24. This is HCF of these two numbers by using fundamental theorem of arithmetic. Now we can find out LCM. LCM told like this, product of the greatest power of each factor. You can consider all factors with the greatest power. Suppose here first one 120 can be the factors like this 2, 3, 5. Here 2, 3. Therefore, we can find each factor, all factors we need to consider with the greatest power. Greatest power. When we comparing 2, both are same, that is 2 cube into here 3 square and here 3, this is the greatest one, that is 3 square, 5. All factors we need to, not need to consider the common, all factors we need to consider for finding. Now we can multiply. That is 2 cube is 8, 3 square is 9 into 5. Now 8 into 9, 72, 72 into 5, 360. 72 into 5, we got the answer is 360. Now we find out HCF and LCM of these two numbers. And one more condition is given here in box. The HCF into LCM satisfy always the product of two numbers. This is the verification. Okay, so we can verify that also. HCF into LCM is equal to product of the two numbers. We already find out HCF and LCM. Now we can find out HCF into LCM. We got answer HCF is equal to 24 into LCM is 360. Now we can multiply that too. That is 36 into 24. One zero is remaining there. Therefore, answer we got 8640. After multiplication of HCF into LCM, we got answer 8640. This is LCF into LCM we already got. Now we can find out the product of numbers also. Product of numbers. So here the numbers are these two, 72 into 120. Here the numbers are 72 and 120. That also we need to multiply. 12 into 72. Zero is remaining there. Therefore, that also we got 8640. We got the same answer here. That's the condition here. HCF into LCM is equal to product of numbers. Okay. If HCF can be find out like this, the small common factor, smallest power, and LCM can be find out each factor, the greatest power. This is by using fundamental theorem of arithmetic, we can find out HCF and LCM. Okay. Okay. And one more question I can explain you based on this fundamental theorem of arithmetic, that is 336 and 54. We can find out HCF and LCM of these two numbers that already you know. Anyway, we can find out factorization first. 336. 336 can be 2, 3 one time, 13 6 times, 16 8. Again 2, that is 8, 84 half of that. Then again 2, that is 42. Then again 2, that is 21. Now 3 and 7. Again 336 can be expressed 336 equal to 2, 1, 2, 3, 4, 4 times is there, that is 2 raised to 4 into 3 into 7. 336 can be expressed 2 raised to 4 into 3 into 7. Then next we can find out 54. 54 2, that is 27, 3, 9, 3, 3. Here 54 can be expressed like this. Only 1, 2 is there. 2 into here 3, 1, 2, 3 times. Therefore 3 cube. The factorization of 336 and 54 already over. Now we can find out HCF and LCM. First we can find out HCF. HCF means the common factor least power. Here the common factor is here 2 and here also 2. The least power is here, therefore 2. Here 3 cube and here 3. The least power is 3. One time, here 3 times. The smallest, okay. For 2 into 3, that is 6. Okay. Now LCM. LCM means all factors we need to consider with the highest power. When we consider 2, the highest power is here. Therefore 2 raised to 4 into 3 here and 3 cube here. 3 cube into one more factor is remaining. All factors we need to consider with the highest power. Okay. Now 2 raised to 4 means 2 into 2 into 2 into 2, that is 16. Then 3 cube means 3 into 3 into 3, that is 27 into 7. Okay, when we multiply this all, we got answer 3024. Okay, after multiplication of this, don't waste time, 3024, that is LCM. Then HCF is equal to this one and LCM is equal to like this 3024. Now we can verify that HCF into LCM. HCF into LCM. Here HCF equal to 6 and LCM is equal to this one 3024. Okay, just to multiply and find out the answer. 6 into 3024. Got the answer? Okay, the answer is 18144. We got the answer like that. Then right side is like this, product of numbers. Product of numbers means we need to multiply these two numbers, that is 336 into 54. We can multiply these two numbers, that again we got 18144. Anyway, we got the same answer here. Therefore, HCF into LCM and product of two numbers, we got the same. This is only the verification. For finding HCF and LCM, we can use the fundamental theorem of arithmetic. Okay. The next question is given like this. Given that HCF of 306 and 657 is given here 9. We need to find out LCM of these two numbers. Don't need to directly. One of the equation, already know the equation like this. HCF into LCM equal to product of numbers. By using that, we can find out H. Okay. From this, HCF can be rewritten. HCF equal to product by LCM. HCF can, from this equation can be rewrite. HCF is equal to product by LCM. The same way LCM also like that. LCM is equal to product by HCF. We can form like this. From this we can form like that. Two more equations we can form like that. HCF is equal to product by LCM. LCM is equal to product by HCF. Okay. By using that result we can use here. Therefore, HCF is equal to HCF of these two numbers is given 9. LCM we need to find out. Therefore, we can start by using like this. LCM is equal to product by HCF. Therefore, LCM equal to product of numbers by LCM. Product of numbers by LCM. Here product of numbers means just we multiply 306 into 657 divided by LCM is 9. No need to multiply and dividing by 9. If you know the multiplication table, just you can simplify that. Now I can cut here 9 and 306 will cut and 30 3 times 3 into 9 27, 3 is remaining and 36 4 times. Now it becomes 34 into 657. Otherwise, we can multiply 306 into 657, then dividing by 9 if you got the same answer. Okay, if you cut like this, it's simple for you. Now 34 into 657. You can multiply that two numbers. We got the answer like this 22338. Like this, we got the final answer. After multiplication of these two numbers, we got the answer. Like everyone know the multiplication, just you multiply. Then you got answer like this 22338. That is the final answer. Therefore, HCF can be found out, product by LCM. LCM can be found out, product by HCF. That equation also we need to use for finding this. Okay.